You are listening to the Information Security and OSINT podcast, episode 9, originally released on May 29th, 2020. My name is Josh Amishav. This week, we're going to talk about automation, specifically around how we combine various Recon tools to automate the initial attack surface mapping. Once we've mapped out what resources our target owns, we can figure out where to focus our efforts. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. You know the easiest way hackers break into your network? By using valid usernames and passwords. Attackers collect millions of leaked credentials from almost daily data breaches, but without having any visibility into which of your employees or users' credentials have been leaked, it's tough to protect against this. Integrate BreachSense's powerful yet easy-to-use API into existing security solutions to prevent account takeover and stop online fraud. Okay, I want to start off by covering a couple more tools that should be in our arsenal as pen testers or bug bounty hunters. ffuf is a very fast web fuzzer written in Go. It's sort of like GoBuster or Deer Search, but on steroids. And I say this because, of course, you can use it for brute forcing default directories and files, but you can also use it for things like virtual host enumeration and parameter and post-body fuzzing. Essentially, you define a marker, which in this case is the string fuzz, F-U-Z-Z, all in capitals. This is a placeholder that ffuzz uses to inject the payload into. You can set a placeholder anywhere in the request. You can also place multiple placeholders, so you can scan for both file names and different extensions like .php or .aspx. And I should note that unlike similar tools, ffuzz does not come with an extensive payload list. Now, there are heaps of these out there. I recommend checking out SecList, the SecList GitHub repository. Another content discovery tool I like is recursebuster. Again, it's similar to GoBuster, but it's recursive. And an interesting bit is that it initially uses a HTTP GET request, so it's quite fast since no response body needs to be transferred back. Once the server responds with a 200, indicating that the web page exists, a GET request is sent and the page is downloaded. And then the web page is parsed for links and fed back into recursebuster for more spidering. In the past, we spoke about mass DNS, which is a high-performance DNS resolver. Basically, you give it a list of potential subdomains, it does a DNS lookup, and then tells you which ones resolve. One of the ways it does this quickly is that it queries multiple DNS servers in parallel. The tool comes with a default resolvers.txt file with pre-populated DNS servers, but some of those servers spoof DNS responses, meaning the DNS server responds with a bogus response when the domain or subdomain doesn't actually resolve to anything. Now, there's another project on GitHub called DNS Validator, which helps solve this problem. You can specify a DNS server or even a URL containing a list of DNS servers, and it verifies that the servers resolve domains properly. For example, you can give it, and this is the example they use, public-dns.info/nameservers.txt, which is a list of close to 10,000 DNS servers, and it verifies them for you. Note, on my home ADSL connection, it took a bit over an hour to verify all the public-dns.info name servers. Last week, we talked about using AMAS to enumerate subdomains. Although, as part of that process, it queries the CertSpider API, it does not import and recursively scan other domains found. We can automate queries to the CertSpider API with our target's domain and parse out the list of other domains listed in the SSL certificate. In other words, when buying a domain, companies often include several parent domains in the same certificate. Now, this is different than a wildcard cert, which may cover everything under its specific domain, like all subdomains under example.com. What I'm after here are SSL certificates that contain other related domains. For example, when querying uber.com, we get back a heap of other domains, including uberinternal.com, which may be interesting. Note that if the cert is hosted on a CDN or other type of shared server, it may generally contain domains that are completely unrelated, so you should verify this before automating the process. Now, once we create our list of subdomains using tools like AMAS, Sublister, MassDNS, and CertSpider, we can then feed this back into AMAS to recursively query every domain within our target. Now, at this point, there are a number of steps I like to take. First, we need to document everything we found. Now, if you're into mind maps, then Maltego's case file can be very helpful. And if you want to keep it simple, I created a bash script that runs scanning tools, then creates a parent directory with the initial domain name I fed the script. Then the script creates subdirectories with each of the subdomains found. Then each of the subdomains found is catted through HTTP probe, which checks if there's a web server hosted on that domain. And then I create a list of websites and use webscreenshot.py, which is a Python script, to take a screenshot of both port 80 and 443. And this is configurable, but this is for an initial recon. I found this very helpful. And surprisingly enough, many times you find that the content on 80 is not identical to what is being shown on 443. I also feed the list of subdomains found through subjack. Subjack is a subdomain takeover tool. Now, just to give a bit of background, when a domain like dev.example.com points to a service like S3 bucket or GitHub page that's been deleted, an attacker can create a bucket or GitHub page using the address that's being pointed to. For example, I had a client this week that had a domain name something along the lines of s3.example.com. When you access s3.example.com in the browser, you got an error message, no such bucket. The specified bucket does not exist. This means that the domain name points to an S3 bucket that anyone can now claim. Now, you'll need to verify the underlying bucket name, but in most cases, you just need to add .s3.amazonaws.com to the domain to verify that the initial full subdomain is the S3 bucket name. You can do the same thing with deleted GitHub pages or Bitbucket. In fact, there's a handy GitHub repository called Can I Takeover XYZ that lists 51 different engines and the fingerprints you can search to check if the page is vulnerable to subdomain takeovers. Now back to subjack. I can automate this entire process by feeding the list of subdomains we've enumerated into subjack, which will tell me if any of the domains are vulnerable. Now that we have a list of targets, I like to run a quick port scan using mass_scan against the list using about 30 different common ports. Later on, we can drill down with Nmap, but that's significantly slower, so this helps initially focus or tell me where I should focus my attention on highlighting potentially interesting areas. At this point, I'll run the content discovery tools that we discussed previously, like ffuz and recursebuster, against the targets, and depending on the engagement type, I'll run curl and dig against the subdomains so that I can save a historic view for later comparison. Now, this can be handy if, for example, later down the line, they add a service like Cloudflare. So if you know the IP address where the web server used to be, you may be able to bypass the WAF by using a host entry and accessing the backend server directly. Then I'll also start looking into other data sources like GitHub for leaked information like AWS keys and passwords. We covered that in episode 7. Shodan is another great data source that perhaps we'll cover in more depth in a future show. But you can use the domains and the CIDR networks reported by AMS to find other interesting services that might be running. Another cloud-based recon tool is cloud_enum, which helps you enumerate public AWS, Azure, and Google Cloud resources. In other words, you define one or more keywords, like the target name, or perhaps strings like auth and key, and then you use either the default brute force and mutations list or supply your own. And cloud_enum uses this to create variations on your keywords and checks if a resource with that name exists in AWS, Azure, and Google Cloud. It will also report if that resource is open or protected. Now, when I say open, I mean a bucket that allows anonymous users to list the contents. Having said that, you'll sometimes find a bucket that won't let you list the contents, but has the permissions messed up and will let you write to it. So it may still be worth brute forcing and checking for write permissions on any buckets found. Also, just be careful in how many queries you send. At some point, the cloud providers rate limit you. So you can use the -t flag to control how many threads are used concurrently. To summarize, at the start of engagement, it's helpful to automate as much of the recon process as possible. For some things like GitHub Recon, you probably want to leave that as a manual process. But for attack surface enumeration, like finding subdomains, related domains like those in a shared SSL certificate, or by reverse whois search, can and should be automated. Once the initial attack surface has been mapped, you can run several tools to find things like unsecured S3 buckets, subdomain takeovers, and default web content that can be exploited. That's it for today. If you have any questions or feedback, please contact me at podcast@breachsense.io. And if you got value from this episode, then please share it with a friend. See y'all next week.